Hello everyone, welcome to another video, and we are going to start exercise 1.2 of General Mathematics class 10. So this exercise is based on LCM and HCF. So what is the basic theory? It says that if you have two numbers A and B, any two numbers A and B, then the relation between the HCF and LCM and these numbers, what is it? So the HCF of A and B, you multiply it with the LCM of A and B, you will get the product of A and B. So suppose let us take two numbers, suppose 3 and 9. So the HCF of 3 and 9 is obviously 3, and the LCM of 3 and 9 is 9. So here HCF into LCM is equal to 3 into 9, that is 27, and if you multiply these two numbers, that is 3 into 9, which is also 27. Okay, so this is very clear, very simple idea that if you multiply the HCF and LCM of two numbers, it will always be equal to the product of those two numbers. So using that theory, we will try to solve the questions given in exercise 1.2. So if you look at the first question of exercise 1.2, you will see express the following numbers as the product of its prime factors. So you have to find the product of, you have to express it in the product of prime factors, means you have to find the prime factorization. So let's start with question number 1 of exercise 1.2. All of you take out your book. This will be easier for you to understand. Take out your book, page number 36 of your book, General Mathematics, and the first question is question number 1, Roman 1. This is exercise 1.2. So question number 1, Roman 1, it is given 140. So find the prime factorization. So here 140, all of you have done this from your junior classes. So it will be 270, 235, 5, 7. So therefore 140 will be equal to 2 into 2 into 5 into 7. So these are the products of the prime factors. Done. Let's do one more if you want. Okay, a number, suppose number 5. 7429. 7429. So if you do the prime factorization here, so this one we can try with 17. We will get 17 4s are 68, so it will be 62. So again we can go for 17 3s are 51, so 119. 119 means 17 into 7. Then we can go for 19, I think 19 2s are 38, 57 3. So these are the three. So therefore 7429 can be expressed as 17 into 19 into 23. So these are the three prime factors. So that is how you solve number 1. Let's move on to question number 2 and see what we have there. These are very simple sums. So the numbers that I will not be solving, try to do it yourself. That will be your task to do. Okay. So number 2, find the LCM and HCF of the following pairs of integers, and you have to verify that LCM into HCF will be the product of the two numbers. Means what I just explained before the start of the exercise. So let's try number 1. Question number 2, Roman 1. It is 26 and 91. Right? Yeah. So 26 and 91, how do you solve it? So here first, let's try to find the HCF. So 26 you can factorize with 2, you will get 13, and 91 you can factorize with 13, and it is 13 into 7. So therefore 26 can be written as 2 into 13, and 91 can be written as 7 into 13. So as 13 is the common factor and this is the highest, so therefore HCF will be equal to 13. Okay. Similarly, also let us find the LCM. So 26 and 91, if you try to find the LCM, we'll go for 13, 2 and 7. So therefore LCM will be equal to 13 into 2 into 7. So it is 26 into 7. So 26 into 7 is 42, 4, 182. So it is 182. So this is the LCM and HCF. Now we have to verify. What you have to verify? So now we have to find the product of the LCM and the HCF. So HCF multiplied by LCM gives us what? Gives us 13 into 182. So try to find this value. So if you multiply 182 by 13, what do we get? We get 6, 24, 2, 3, 5. Then we have 182. So it is 6, 6, 13, 2. 2, 3, 6, 6. Now let us try to find product of the two numbers. and it is 26 into 91. If we find the product of these two, so 26 into 91 will give us 54, 5 and 18, 23. So it is 6, 6, 3, 2. So again 2, 3, 6, 6. So that means the LCM and HCF product, the product of these two numbers and the product of the two numbers given both are same. So therefore HCF into LCM is equal to 26 into 91. So hence we have verified the given sum. Okay. So in the same way you will try to solve question number 2 and 3. These are same type. First you take question number 2 numbers, you find the HCF, then you find the LCM. Then this is done. This is the finding the HCF and LCM part. Then you have to verify. So how to verify? You will take the two numbers, the HCF and the LCM, you will find their product. You will take these two numbers, the given two numbers, and you will find their product, and you will see that the two numbers are equal. Now there is a way to check whether you have done the HCM and LCM correctly or whether you have done some error. If this product is not equal, that means there is some mistake in the sum. So you can rectify it there. Okay. So that's how we have verified question number 2. Let's move on to question number 3 and find the HCF and LCM of the following integers by applying prime factorization. So I will do one. So using prime factorization you have to find the HCF and LCM. These things we have done in previous classes, so these are very easy. I will be doing only one of those. So question number 3, let's try number 1 again. 3, 1. Question number 3, Roman 1. So we have 12, 15 and 21. 12, 15 and 21. So how do you do this? So first let's try to find the HCF. So here we will do the prime factorizations individually. So we'll go for 2, 6, 2, 3. For 15 we have 3 and 5, and for 21 we have we have 3 and here 7. So therefore 12 can be written as 2 into 2 into 3. 15 can be written as 3 into 5, and 21 can be written as 3 into 7. So we can see the 3 is the common factor. So therefore the HCF will be equal to 3, as 3 is the only common factor. So HCF is 3 highest common factor. Now let's find the LCM. So let us take all the 3 together. So using 3 we can go 4, then we have 5 and we have 7. So then we can go for again 2, but this will be of no use. So here are the numbers. So therefore LCM will be equal to 3 into 2 into 2 into 5 into 7. So 3 6 are 3 to the 6, 6 5 are 30, 30 to 210, 420. So here we have the HCF and the LCM, and we have done it through prime factorization method. Very simple, and these things you have done long back in your previous classes in class 7, 8, 9. Now let's move on to question number 4, and what has been asked is two numbers are given, 306 and 657, and they have found out the HCF. The HCF is given as 9. You have to find the LCM. So we will use it using the property that we have learned at the beginning, that the product of the two numbers will be equal to the HCF and LCM. So let's write what is given. Question number 4. What is given? It is given that HCF of 306 and 657, 306 and 657 is equal to 9, and we have to find the LCM. What is the value of the LCM? So we know, what do we know? That HCF into LCM is equal to product of the two numbers. Okay. So what is HCF? HCF is given as 9 into LCM is equal to product of two numbers. What are the two numbers? 306 and 657. So which implies LCM will be equal to 306 into 657 by 9. So let's try to find 27, 9 ones are 9, 3, 4. So LCM will be equal to 34 into 657. So 657 into 34, 28 to 20, 22 to 26, 21 to 15, 16, 17, so 1, 19. So 8, 3, 13, 1, 12, 1, 2. So it is 2, 2, 3, 3, 8. This is the LCM. So very simple sum. You need to know this property. HCF into LCM is equal to product of two numbers. Okay, and that's how you can find the required LCM, or if you are given the LCM, then you can find the HCF also. Let's move on to question number 6. Check whether 6 to the power n can end with a digit 0 for any natural number n. So how do we solve question number 5? We have to check whether 6 to the power n is divisible, ending with 0 or not, with the digit 0. So we have 6 to the power n. Now for any number, if it is divisible, if it is ending with a 0, that means it must be divisible by 5. Suppose you take 410. Now 410 is divisible by 5. 82 into 5 is 410. Any number that ends with 1 0 or any number of zeros, it must be divisible by 5. That means for any number 6 to the power n, that number must contain 5 as the prime factor. So now 6 to the power n can be written as 2 into 3 whole to the power n, that is 2 to the power n into 3 to the power n. So we know if any number ends with 0, then it must have 5 as its prime factor. But 6 to the power n only contains 2 and 3 as its prime factor. I hope you understand. We must have 5 in this number, but if we factorize 6, then we get 2 into 3, which is to the power n, any power, it can be any power. So ultimately we will get 2 and 3 only as the prime factors, no other number. That means 5 is not present in this. So as 5 is not present in this in the factorization of this number, that means 5 is not a prime factor, therefore this number can never end with 0. So therefore 6 to the power n can never end with 0. Okay, I hope you understood. So keep this in mind, that if any number has to end with 0, it must contain 5 as the prime factor. So whatever number you are given here, try to find the factorization of this number. If this contains a 5, then it will be divisible. Then it can end with 0. If it does not contain a 5, it cannot end with 0. As simple as that. Let's move on to question number 7. So there is a circular path around the sport field. Sonia takes 18 minutes to drive one round of the field. Ravi takes 12 minutes for the same. Suppose they both start at the same point and at that time and go in the same direction. After how many minutes will they meet at the starting point? So one person, that is Sonia, she takes 18 minutes to cover the field and Ravi takes 12 minutes. So after how much time, if they start from at the same point at the same time, then after how much time will they meet again at the starting point? Now this will be in multiples, because in the first 12 minutes Ravi will come back, but Sonia will take 18 minutes, so she will take longer amount of time. That means the answer that we are going to get is going to be in the multiples of 12 and 18. There must be one common multiple of 12 and 18 where both Sonia and Ravi will meet. So multiple of 12 and 18 means we have to find the common multiple, and common multiple means and in the lowest possible time, obviously in the least amount of time, when will they again meet? So that will be the LCM, least common multiple. If we can find the LCM, then we can get the answer. So I want you to do that by yourself, because you need to find only the LCM. I hope you understood. One takes 12 minutes, one takes 18 minutes. So after how much time they will meet? So it will obviously be more than 12 and 18. That means the multiples of 12 and 18. So multiple means you have to find the common multiple where they can meet. So it will be the same amount of time. So time must be the same. So same means it has to be a common multiple of 12 and 8. And obviously we are going to find the least amount of time, not the maximum, because maximum can be infinity. So the least amount of time we need to find. So what is the least amount of time? That will be the least common multiple, that is LCM. So if you find the LCM of 12 and 18, that's when you know after how many minutes they are going to meet. So try to solve question number 7 by yourself. Okay, we missed question number 6. Let's see how to do question number 6. Another very easy sum. They have given two numbers and they have asked why these are composite numbers. Composite means the numbers which are not prime. So any number having more than one common factor will be called the composite numbers. So what numbers are given? We are given 7 into 11 into 13, we are given 7 into 11 into 13 plus 13, and we are given 7 into 6, 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5. Okay, so why these are composite? So here you can see, here we have two terms. In the first term we have 113, here also we have 113. So if I take 13 common, then I can write 7 into 11 plus 1. That means 13 is one of the common factors. In this case, we can take 5 common. So here we have 7 into 6 into 4 into 3 into 2 into 1 plus 1. So as this number is divisible by 13, it obviously will be composite, and as this number is divisible by 5, it will also be composite. What is a prime number? If a number is only divisible by 1 and the number itself, then it is called a prime number. But if it is divisible by any other number, then it is a composite number. So here this number is obviously divisible by 1, any number is divisible by 1, but it is also divisible by 13. So it is a composite number. Here this number will obviously be divisible by 1 and it is also divisible by 5. So again it is a composite number. So since 7 into 11 into 13 plus 13 is divisible by 1 by the number itself, obviously the number itself 1 and 13, so it is a composite number. Similarly, since 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 is divisible by the number itself, then we have 1, and also it is divisible by 5, so it is a composite number. So that's how we solve this sum, question number 6. Now let's move on to question number 8 and see what the sums ask us to do. If the soldiers in a regiment can be stood in the same rows consisting of 15, 20 and 25 soldiers. Okay, find the least number of soldiers in the regiment. So the number of rows in which the soldiers can be stood, they can be arranged, are 15, 20 and 25 numbers of soldiers. So some number of rows. So number of rows is not given. So they have to be arranged in some number of rows, so that the number of soldiers must be in the rows. The number of soldiers must be 15, 20 or 25. Means you can have those rows with 15 soldiers in each row, or 20 soldiers in each row, or 25 soldiers in each row. Then you have to find the least number of soldiers in the regiment. So what should be the least number of soldiers so that they can be arranged with 15 numbers in each row, 20 numbers in each row and 25 numbers in each row? That means you have to find the multiple of these numbers. So a common multiple of 15, 20 and 25 will give you the least number of soldiers. That means you have to again find the LCM. So question number 8, Roman 1, you have to find the LCM. Try it out yourself. Very easy sum. Question number 2, 8.2. A bell rings every 18 seconds. Another bell rings every 60 seconds. If these two bells ring simultaneously at an instant, find after how many seconds will the bells ring simultaneously again. So two bells start ringing at the same time. One will ring after every 18 seconds and one will ring after every 60 seconds. So it is just like question number 7, where Sonia comes back after 18 minutes and Ravi comes back after 12 minutes. Again you have to find the common multiple, that is you have to find the least common multiple, that is LCM. 18.2 is also about LCM. Moving on to question number 8.3. A radio station plays Assam Sangeet once every 2 days. Another radio station plays the same song once every 3 days. So it is the same type of question. So how many times in 30 days will both the radio stations play the same song on the same day? So you have to find that. Okay, let's try to do this. This is a little bit different. So question number 8, number 3. So obviously you have to find the LCM. So question number 8, 3. Number of days after which the first station plays the song is equal to 2, and number of days after which the second station plays the song is equal to 3. So one radio station plays the song after 2 days and another radio station plays the song after 3 days. Now we have to find in 30 days how many times will they play it together. So first let us try to find out after how many days do they play it together. So suppose today is Monday, both the stations are playing the same song. Then on which day will they play the same song again? That means again you have to find the LCM. So it will be the multiple of these days. So you have to find the common multiple. So therefore number of days after which both the stations play the song simultaneously is equal to LCM of 2 and 3, and LCM of 2 and 3 is obviously 2 into 3, that is 6. So after every 6 days they play it simultaneously, means together. So in 30 days how many times will they do? Therefore number of times they will play it together in 30 days is equal to, obviously divide 30 by 6, you will get the answer 5. After every 6 days they play it together. So in 30 days means in 1 month how many times will they play? So if they play suppose on the 6th, suppose now May month is going on, suppose they are playing it together on 6th of May. Then they will again play it on 12th of May, then on 13th of May, then 14th of May. Okay, I am going to repeat. First 6th of May, then 12th, then 18th, 24th and 30th. So in 30 days they can only play it 5 times together. So here is the answer 5. So if you divide 30 by 6. So first find the LCM, then you will know after how many days they will play it together, and then in 30 days if it is given 60 days then divide 60 by 6. If it is given 100 days then divide it 100 by 6. So like this you have to find the answer. So we are done with exercise 1.2. I hope you have understood. If you have any confusion, make sure you ask me in the comment section. I will be there to help you out. So thank you everyone for watching, and until next time, cheers.